Let's take a look at exercise 21.6, daily activity and obesity. We can conclude from examples 21.2 and 21.3 that mildly obese people spend less time standing and walking on average than lean people. Is there a significant difference between the mean times the two groups spend lying down? Use the four-step process to answer the question from the data in table 21.1. Follow the model of examples 21.2 and 21.3. Take a look at our table. All right, it's perfect. Okay, so I use my TI-30 XIIS, the little blue calculator, to help me find X bar and F for the information in the lying down column. Okay. All right, so I inputted this 10 pieces of data, and secondly this 10. So in one go round, I did the one bar in the TI-30, and I got the X bar and S from here. And we'll call this X bar 1 and S1. Same thing, I put this data through the calculator, and I got myself an X2 and an S2. Okay, and remember the S's are like S sub X or X sub S, one or the other. Let's see. Okay, so our four-step process is to state the problem, plan the problem, solve the problem, and make a conclusion for the problem, right? So let's take a look at stating the problem. Does the average time lying down differ between obese people and lean people? That's our problem. That's what we're asking ourselves. Oh, obese with one S. What do you think going in? They said, yes, there was a difference in standing and walking. I don't remember if they told us about sitting. We can conclude from example 21.2 and 21.3 that mildly obese people spend less time standing and walking on average than lean people. Is there a significant difference between the mean times of groups lying down? So they didn't talk about the sitting column at all. Oh, sorry. I think it will have cleared out on my notation too. Yeah. Okay, so we stated our problem, right? Is there Is there a difference between obese people and lean people in the time they lie down? And we also need to make a plan, right? The plan portion is then what's our null hypothesis and what's our alternative hypothesis, right? We test the null hypothesis at mu1 equals mu2. So we say there is no difference between the average amount of time a lean person lies down versus an obese person, right? So we think there is no difference. Versus the alternative hypothesis that there is a difference. And we got that from when we stated the problem, which I accidentally erased, which the question itself just asked us, does the average time differ? So I'll shorten that for us. But that's our keyword there, differ. We know from that keyword that we need the not equal to symbol. Okay. All right. Where, let's define these things too. Oops. Where U1 is the mean time lying down for the lean group, and mu2 is the mean time lying down for the second group, the obese group. All right, and now it's time to solve. We assume that the data come from SRSs of the two populations. Simple random samples. And also in example 21.2, they had a discussion for the conditions of inference that apply to this problem. So we don't have to do that. The simplot does not indicate non-normal data. So we proceed with the t-test. Two samples. All right, now when I put this in the calculator, I got an X bar 1 of 501.6461 and a standard deviation of 52.0449, and I got a X bar 2 of 491.7426 and a standard deviation 46. 0.5932. Now, N1 is 10, and N2 is also 10, right? There's 20 individuals, 10 of which are in the lean group, the other 10 of which are in the obese group. The standard error for this problem is S1 squared over N1 plus S2 squared over N2 rooted. And I calculated that to be 22.0898 and a t-score, which is the difference of the means divided by the standard error. I found that to be 0.448. Using the degrees of freedom of the lesser N1 minus 1 or N2 minus 1, they're both equal to 9. So we have degree freedom equal to 9. When we go into table C, we find that we have a p-value that's greater than 50%, greater than 0.5, because our table doesn't even go up that far. Now, if you had used software, your degrees of freedom would be 17.8, and the test would yield a p-value of 6.593. So in either method, we had a p-value greater than 0.5 or a p-value of 0.6593 by TEC, right? That's our TEC answer. And now we need a conclusion, right? Conclude, it's the 4-step process. So we have a p-value that's very large. Like it's not smaller than any normal alpha that we use, right? Alpha, for example, of 5% is pretty common, 95% confidence interval. Alpha 0.01, 99% confidence interval. This is a 0.5. That's way in the middle of possibilities, right? So we can't conclude that there's a difference. So what we will do, erase these. I don't think it will let me. There's no eraser on this pen. There's a undo, but only undo does a certain amount. Okay, so the full conclusion then. These are what we normally compare, right? Our p-value is large. So we conclude there is no evidence to support a conclusion that lean people spend a different amount of time lying down on average than obese people. There's no difference to support a conclusion that lean people spend a different amount of time lying down on average than that of obese people. Step 4.